వెల్కమ్ బ్యాక్ టు ఈ క్లాసెస్. ఫిజిక్స్లో అత్యంత కీలకమైన చాప్టర్ మెకానిక్స్. అందులోనూ సెంటర్ ఆఫ్ మాస్కున్న ప్రాధాన్యం అంతా ఇంత కాదు. మరి దానికి సంబంధించిన మరిన్ని అంశాలను తెలుసుకుందామా?
Let us consider the case of a uniform straight rod. Let us consider the example of a uniform straight rod. A rod has mass distributed. So many tiny or minute particles make up the rod. There are many particles which are very small and all are close to each other. We can't identify individual particles. Therefore, this comes under the category of uniform mass distribution. So, let the mass of this rod be m, length of the rod be l. Let that be located here. Now, for us to give the coordinates of center of mass, we have to choose coordinate axes. Let us assume that we choose coordinate axes which are parallel x-axis of which along which the rod is located. Rod is lying. Let y-axis be perpendicular to this. One end of the rod be at the origin of the coordinate system. Let the one end of rod A, let us call it as A end, B end, let A be the rod. So, how to determine the center of mass of this? Since the mass is distributed on x-axis, only center of mass will have x coordinate. Y coordinate and z coordinates are 0 because there is no y and z coordinates of the individual particles. From this, first conclusion is ycm is equal to zcm is equal to 0. The coordinates of this rod will be only along x-axis, y and z coordinates are 0. So, how to determine this? The procedure, imagine the rod be divided into small elements. So, let us imagine the rod be divided into small elements. Consider an element of length dx situated at a distance x from this origin. So, we are imagining the rod be made up of small particle, infinitesimally small particles. Such particles we are considering here which are of distance dx. Mass distributed in dx, we are treating it as infinitesimally small element. So, what is the mass of this element? Let dm be the mass of the element of the rod lying in this distance dx. How to determine this? Mass of this element is mass per unit length into dx, where mass per unit length usually is called linear density of mass, linear mass density or linear density of mass. Mass divided by the length over which it is distributed. Units are, in Eamcet system, units are kg per meter. These are the units of the linear density. Therefore, mass of this element is linear density of the rod into length of that element. That is the mass. Means we are treating this element, all the element of the rod here, that as a small particle. Then how to calculate xcm? Xcm as the formula is equal to x. X is the distance of this particle into dm, mass of that